Okay. Bismillahirrahmanirrahim. Now we did, that was the last one we did in the previous video. Now we'll do this one. Yeah, let me remind you about what we did before. I have u tan x over 2. Now, when I have x equals 0, very clear u equals 0. When I have x equal alpha, which is 2 tan inverse something, then u will be tan of 2 tan inverse of minus 3 over 2, and that will be minus 3. Okay. And also I have du x will be 2 du over 1 plus u square. Sine x is 2u over 1 plus u square. So sine x is 1 minus u square over 1 plus u square. I plug everything in this integral. So I have I is what? Minus 3 to 0 of what? Dx is 2 du over 1 plus u square over cosine x is what? 1 minus u square over 1 plus u square minus 3 sine x. That means minus 6u over 1 plus u square plus 3. Now, I need to do the calculation. This over 1 plus u square, everything. That gives me 1 minus u square minus 6u plus 3 plus 3u square, which will make it minus 3 to 0, 2 du over 1 plus u square over, this is 2u square minus 6u plus 4 over 1 plus u square. This is cancelled. Also 2 also cancelled. So you have what? Minus 3 to 0 du over u square minus 3u plus 2. And that is what? U minus 2, u minus 1. So this is minus 3 to 0, a partial fraction plus b over u minus 1 du. Cover this, substitute 2, you get 1. Cover this, substitute 1, you get minus 1. So that will be ln u minus 2 minus ln u minus 1 from where to where? From minus 3 to 0. Yeah, that will be ln 2 minus ln 0, ln 1, which is 0. That's it. Minus, substitute minus 3, that will be ln 5 minus ln 4. So I have what? Ln 2 plus ln 4 minus ln 5. This is product. It will be ln 8 minus ln 5. And this will be quotient ln 8 over 5. And that will be the answer. Yeah, easy one. 1 plus sine theta cosine plus cosine theta. I think we did it before. Yes, this is the one. It's ln 1 plus tan x over 2. It's ln 1 plus tan x over 2 from 0 to pi over 2. That give me what? Ln 1, which is 0. That will be... No, I need pi over 2 first, sorry. This pi over 2. I have pi over 4, so it will be ln 1 plus 1 minus ln 1. That give me ln 2. That's it, minus ln 1, which is 0. Just substitution. We did it before, so I'm just using that. 1 over 1 plus cosine x minus sine x. I don't know if we did it before or not, but let me do it again. Do the substitution. U equal tan x over 2. Substitute, I have 2 du over 1 plus u square over 1 plus cosine, which is 1 minus u square over 1 plus u square. Sine is 2u over 1 plus u square. Now I have what? 2 du over 1 plus u square over, this is over 1 plus u square. I have what? 1 plus u square, 1 minus u square minus 2u. Okay, this is cancelled. So this one cancelled. I have 2 du over 2 minus 2u. That will be integral du over 1 minus u. And that is what? I need minus and minus. So it's minus ln 1 minus u plus c. And that will be minus ln 1 minus tan x over 2 plus c, which is this one. Now let me do this one. I have integral dx over sine x plus tan x. That will be what? Dx over sine x. If I'm using this tan x over 2, I need sine and cosine only. So that will be plus cosine x plus sine x over cosine x. That give me what? Dx over sine x cosine x plus sine x over cosine x. That give me cosine x dx over sine x 1 plus cosine x. Now I use the substitution. U equal tan x over 2. I plug everything. I have this is 1 minus u squared over 1 plus u squared times 2 du over 1 plus u squared over sine x is what? 2u over 1 plus u squared. This is 1 plus 1 minus u squared over 1 plus u squared. Okay, do the calculation. I have what? 2, 1 minus u squared du over 1 plus u squared all square. This is the numerator. The denominator is what? This is what? This is 1 plus u squared plus 1 minus u squared over 1 plus u squared. Cancelled, cancelled, you have 2. So you have 4u over 1 plus u squared all square. So this is cancelled. So I have what? Half outside 1 minus u squared over u du. That give me half ln 1 over u minus u du. And that will be half ln of u minus u squared over 2. Don't forget half times everything. That will be half ln tan x over 2 minus 1 over 4 tan square x over 2 plus c, which is this one. Yeah, these are the questions from the book, which I think we can do. If we did some of them, they're not difficult, but be careful about sometimes the calculation. For example, in this one, need to change it into 1 plus cosine square. Yeah, I think if I change it into sine square, that will be 1 minus sine square, and then I do the calculation. Yeah, try to do these problems using this substitution. U equal tan x over 2. Not all of them, some of them. Yeah. And this one, no need. Very clear. This one, maybe you need to change things into. Yeah. Think about it. See how things are going with these problems. Okay. Now let me move to. This is there was a section in Stewart's book where he's talking about strategy for integration. Now we have different methods. What are the best ways, or the way to think about the problems? Usually, I think one of the best things to do is try to do one or two steps in your head. I think that to see how the things will progress. So this is a good strategy in general, but there are some general hints, and this is what we will do here. So this is, we simplify the integrand. We'll take it in detail, look for obvious substitution, classify the integrand. These are the classification, either trigonometric function, or rational function, or integration by parts, or radicals. Try again, try substitution, try parts. Okay, let me go in details about this strategy. First, always it's good to simplify the integrand. Sometimes the use of algebraic manipulation or trigonometric identities to simplify the integrand and make the method of integration obvious. For example, if you have this, you just do multiplication. Now integration is easy. Tan theta over secant square. Yeah, you can think of change it into sine cosine. It's only sine 2 theta, which is easy to do. Sine x plus cosine x all square. It's only this, which is easy to do. That will be u du. U du, that will be, which is easy to do. So sometimes doing some, it's simplified and if possible. Look for an obvious substitution. Yeah. If you look at this with apart from constant factor. Sometimes times a constant, that will help. They always, you need to think about this obvious substitution. This is one of the first things to start with. Classify the integrand according to its form. What are the things we have? If you have trigonometric functions, then I know if product of powers of sine and cosine, there is a way about the powers. Tan and x, even or odd, tan secant, cosecant, and this is what we did in 8.3. This is what they mean by trigonometric function. If it is a rational function, then either it's d over u, like what obvious substitution, like this one, or you can do partial fraction, like what we did in 8.5. To simplify the integrand in a way that you can integrate by parts. If it's a product of a power of x, polynomial, and transcendental function, trigonometric, exponential, logarithmic, all of these things, then by parts will work. Yeah. Radicals. This is some of the things you need to deal with, the radicals. If it is square root x squared plus a square root x squared minus a square, square root a square minus x squared, then each one of them has a specific substitution so that you can deal with the integral, and that's what we did in section 8.4, trigonometric substitution. Now, if you have the nth root of a linear expression, take this as a common, take this as substitution, and then the integral will be reduced to something you can do usually. Remember that as method we have substitution and parts. Try substitution. Yeah, if not, try parts. So sometimes if you have product, if you have only single function, like integral of tan inverse, integral of sine inverse, integral of ln x, this you need by parts. Manipulate the integrand. Sometimes you need to do some algebraic manipulation. For example, 1 minus cosine x. You need to multiply it by 1 plus cosine x over 1 plus cosine x to make it like this, which is easy to do. This is what this is. This one is cotan cosec, which is you can integrate easily. Relate the problem to previous problem. Sometimes you do a problem, you reach a problem that it was done before, secant cubed. For example, it was done in this example, in section 8.2, example 5. So sometimes you need to relate the problem, use similar methods. Sometimes it's not only one method in the problem. You have different methods in the problem, substitution with partial fraction, or substitution with by parts, and so on. These are some general rules. Okay. Now let me do this, especially most of the problems I will do, it's about the square root or the nth root in general. This is this one. Okay, and other problems, just some collecting problems from there and there. Okay, so this case, as they said, in this, I will take u to be the integral, to be the radical. So I take u cube root of x. Okay, what will be u cubed is equal to x? That will help. Then 3u squared du equal dx. So I have dx now already. Now I change everything. If x is 1, then u is 1. If x is 8, then u is 2. Then I have what? 4 x, which is u cubed, times 3u squared du, which is the x, over x, which is u cubed, plus cubic root of x, which is u. Now I have everything in terms of u, and it seems to me is an easy function to integrate. So let me do the calculation. Okay. What will be that? It will be, now use substitution. Now this is 12 u to the power 5 du over, I took u common factor. I have 1, or I have u squared plus 1. Okay, so at 12 u to the power 4 du over u squared plus 1. Okay, it means the degree of the numerator is more than the degree of the denominator, so I need the wrong division. That give me what? 12u squared. Do the multiplication. That's plus, minus, minus. I have minus 12u squared. I need to continue because the degree is equal the degree of the denominator. Then I do the multiplication. I have minus 12. That will be plus 12. So this one is integral from 1 to 2. 12u squared minus 12 plus 12 over u squared plus 1 du, which is an easy integral to do. Okay. That give me what? 12u squared is what? 4u cubed minus 12u plus 12 tan inverse of u, which is very clear. This is from 1 to 2. From 1 to 2. Okay. That give me what? Yeah. I need to be careful. I think I need the space. So let me do it here. 4 times 8, this is 32, minus 24, plus 12, tan inverse of 2, minus, substitute the 1, you have what? 4 minus 12, tan inverse of 1, that is pi over 4, plus 12 times pi over 4. That gives me what? This is 8, and this is minus 8 times minus, I have 16. This is what? Minus pi over 3. And I have 12 tan inverse of 2. So this is minus 3 pi, sorry. 12 over 4, so it's minus 3 pi. None of them is pi over 3. So this is 16 minus 3 pi plus 3. That's one balance. The same thing here. I will let here what I will do. I will let u to be square root of x. What will be what that means u square equal x. I'll use this trick. So I have 2u du equal dx. I have dx ready. That will be 2u du over x is what? Is u square, and this is plus u square times u, which is easy one. That will be what? We have 2u du over u square times u square plus u cube. So it's 1 plus u. This is cancelled. So you have 2 du over u 1 plus u, which I need partial fraction now. So it's substitution with partial fraction. The previous one was substitution with long division and then a regular integral. So you have 2. This is, I'll make it a over u plus b over u plus 1 du. Yeah, cover method. This is u0. So that will be 1. And that minus 1. That will be minus 1. Okay, so you have 2 ln of u minus ln of u plus 1. In other words, plus c. Huh? This will be 2 ln u over u plus 1 plus c. Now retain the u. That will be ln square root of x over 1 plus square root of x plus c, which is this one. Now I have square root of the square root. Yes, how to do this? Okay. Square root of the square root. I have square root of the square root plus 1. Huh? So I take the same thing. Let me take this one. I take it to be u square. This way I get rid of the square root, the bigger one. Then do the calculation. That means the square root of x is u squared minus 1. Do I need this? But it means, yeah, the square root of x is u squared minus 1. I need x. So x will be u squared minus 1 all square. Now what will be dx? It will be 2 u squared minus 1 times du times 2u du. Okay, now I plug everything here. If x is 0, then u squared is 1, then you have u equal 1. Yeah. If x equal 4, then I have square root of 5. That will be square root of 5. Okay. Actually, I'm taking u as square root of the square root of x plus 1. This will be my u. So put 0, that will be 1. Put 4, that will be square root of 3, not square root of 5. Sorry. That will be square root of 3. Okay. This is my u. So u squared equals square root of x plus 1. And I did the calculation. Now I plug everything. That will be 2 u squared minus 1, 2u du. This will be dx, and that will be u. Now this u will go with that u, and the result is very easy. 4 u squared minus 1. Let me take the 4 outside. Du from 1 to square root of 3. So that will be 4 u cubed over 3 minus u from 1 to square root of 3. It will be 4. Square root of 3, that will be 3. Square root of 3 over 3 minus square root of 3 minus 1 over 3 minus 1. This will be square root of 3. This is 0. 1 over 3 minus 1, that will be minus 2 over 3. That will be 4 times 2 over 3, which is 8 over 3. So this is the trick. I take all of this to be u. So I have u square, and then the rest is just calculation. Now, what I will choose to get rid of this square root, I'll take u to be x or 1 over. Let me do the rest. Then I have u cubed equal x. So 3u squared du equal dx. Plug the numbers. 1, 8 to the power 1 over 3, this is 2. Dx is 3u squared du over x is 3u cubed. This one is what? I have x is u cubed. U cubed, it will cancel with the cubic root. Then I have u squared plus u squared plus 3u squared. Very clear. I have 1 to the power 2. This is 3u squared. I have 3u squared also here. And I have u plus 1 remaining. This is cancelled. خلاص, done. Then u plus 1 from 1 to 2. That will be what? Then 3 minus then 2. What is this? Yeah. Now this is, I need to be careful. To get rid of the square root, I need to rewrite this in terms of sign, because I have 1 minus 2 sine square 4 over 2, which is 2 theta. So this one, if I plug it, then 1 minus cosine 4 theta will be 1 minus 1 plus 2 sine squared 2 theta. So I get rid of this. So I have 2 sine squared 2 theta, which I can't put it inside the square root easily. Now I have what? Minus pi to the power minus pi over 4 minus pi over 4 from minus pi over 4 to 0. And all of this, it's the square root of this, which is square root of 2 sine 2 theta d theta. Be careful, wait. It's not sine 2 theta d theta. It's absolute value of sine 2 theta. Note a square root 1 minus cosine 4 theta is a square root of 2 absolute value. Square root of sine square is absolute value. Sine 2 theta. And from this interval, sine is negative. So I need minus square root of 2 outside. And I have sine 2 theta. Actually, make this plus, and this is put the sign minus here, because it will be cosine and integrate. That will be times 1 over 2 cosine 2 theta. Don't forget, this is from minus pi over 4 to 0. From minus pi over 4 to 0. That gives me what? Cosine 0 is 1, square root 2 over 2. Sine pi over 2 is 0, خلاص. Actually, if you rationalize it, that will be 1 over square root of 2, which is the way they write it. The x over 1 minus sine x. Yeah, I can multiply by 1 plus sine x over 1 plus sine x to get what? 0 to pi over 3. 1 plus sine x dx. 1 minus sine square, which is cosine square. And that is what? 1 over cosine square. Let me do in steps. Plus sine x over cosine square x dx. That will be from 0 to pi over 3. Huh? Everything from 0 to pi over 3. That will be secant x. Yeah, I can do it at the same time. From 0 to pi over 3. Plus, this is what? If you notice, this is sine over cosine times 1 over cosine x dx. From 0 to pi over 3. What is secant pi over 3? That will be 2. secant 0 is 1. That 2 minus 1 plus this is tan secant. What's the integral of tan secant? Sorry. Wait a minute. What is this? This is secant square. Integral. Let me do it in steps. This is secant square x dx. And this one, I have sine over cosine times 1 over cosine. So it's tan secant x dx. Yeah. That will be tan x, not secant, from 0 to pi over 3. And secant x from 0 to pi over 3. What is tan pi over 3? It will be square root 3 over 2 over half. That will be square root of 3. Tan 0 is 0. That's it. Secant, that will be 2 minus 1. So the answer 1 plus square root of 3. Which is this one? Not difficult, but I was in rush. Square root 1 plus x over x. I'll take u, square root 1 plus x. So u squared equal 1 plus x. We have 2u du equal dx. Plug everything back. You have what? U 2u du over x, which is u squared minus 1. Okay. Now I need the long division first, or let me do a trick. I can take 2 outside. I have u squared over u squared minus 1 du. This u squared, I can write minus 1 plus 1. Instead of doing the long division, I can use this trick. So that will be 2 u squared minus 1 over u squared minus 1 du plus 1 over u squared minus 1 du. Everything times 2. This one, I need the by parts. Partial fraction, I mean, which is, let me do it here. This is u minus 1, u plus 1. That will be a over u plus minus 1 over b over u plus 1 du. Yeah, what is a? Cover this. A will be half. Then cover this. B equal minus half. So that will be half. Then u minus 1 minus half. Then u plus 1 plus c. So I have half. Then u minus 1 over u plus 1 plus c. Okay, plug everything here. That is 1. So I have 2 times u. And this one is plus half. Then u minus 1 over u plus 1 everything plus c. Now return everything 2 times u. What is u? Square root 1 plus x. 2 times half, that will be 1. Plus ln. Square root absolute value. Square root 1 plus x minus 1. And this is square root 1 plus x plus 1. This is positive, so I can take it out, take it outside the absolute value. That will be my answer. Square root of x, ln square root of x. Yeah, I let u equal square root of x. U squared equal x. So du equal dx. Okay, but I will do, I don't need this. Yeah. Maybe, okay. 2u du equal dx. So I have what? U, ln u times 2u du. Okay. That give me what? Oh, let me say it w better. Because I need by parts. And usually I work by parts with u. So I have 2w dw equal dx. And I write everything times w. So when I use the by parts, I take u and v. I have what? W, then W, dx is 2W, dW. Okay, so it's what? 2, take the 2 outside, who cares? W square, then W, dW. Very clear, this is by parts. I take U, because of that I did not do it in terms of U, then W, and dV is W squared dW. So V is W cube over 3, and du will be dW over W. 2 by parts, don't forget the 2 is outside. I have what? W cubed over 3 ln W minus integral of W square over 3 plus C. That gives me dW. That will be 2. I have W cubed over 3 ln W. This is what? This is W cubed over 3 times 3 over 9, and that plus C. Now retain W. I have to x, this is x to the power half, so that's, let me make it in power, x to the power 3 over 2 over 3, then x to the power half, or then جذر square root of x, minus x to the power 3 over 2 over 9. I have 2 outside. I take x to the power 3 over 2, the way he was doing it, over 3 also. I have what? Then square root of x minus 1 over 3 plus c, and I have this. The average value of this, that will be what? Okay, yes, I will do f average. I will stop with this one. It will be 1 over 1 minus 0, integral from 0 to 1, x, tan inverse of x dx. I need to do this by parts. So I let u tan inverse of x dv x dx. So du will be what? Dx over 1 plus x squared, and v is x squared over 2. So this one is x squared over 2 tan inverse x from 0 to 1 minus integral half outside x squared over 1 plus x squared dx. I'll use, okay, this one substitute. I have half times pi over 8 minus 0. Okay, this is minus half. Then I use this trick, plus 1 minus 1. So what's inside the integral? It's 1 minus 1 over 1 plus x squared. That from 0 to 1 dx. Now it's easy to do. This is pi over 4 minus half. What is this? X minus tan inverse x from 0 to 1. That will be pi over 4 minus half. What is this? 1 minus pi over 4, 0, 0. That's it. Then I have pi over 4 minus half. It's not pi over 4. This is pi over 4. This is pi over 8. What is this? This is pi over 8. Minus half plus pi over 8. That gives me pi over 4 minus half. Watch this. Okay. Let me stop the recording. I have only few questions, but I don't like to have long videos. So I will stop the recording. Thank you.